Welcome everyone to your science class, and today we are going to start a new chapter, acids, bases and salts. We will begin with acids. We'll see what are acids, what are their examples. We'll also see what are some of the substances which we are aware of but we don't know which type of acid is present in them. So we'll have a look on them also. Then we'll see what are the different types of acids, weak acids, strong acids, concentrated and dilute acids, the properties of acids and their uses. Now children, let me know, does all the food that we eat taste the same? No. The food may be salty or sweet, sour or bitter. But why do you think different foods have different tastes? Food contains chemicals that give it taste. Sugar, jaggery, they are sweet. Common salt make food taste salty. Some chemicals in food make it taste bitter also. Vinegar, lemon juice, orange juice, they taste sour. To understand this, let's perform an interesting activity. In this activity, we have to taste certain things. But mind it that do not taste or touch anything unless you are asked to do so. For this activity, we have to collect the samples of certain things which we have to take. For example, small amounts of lemon juice, orange juice, grape juice, small amounts of tamarind, baking soda, common salt, vinegar, curd, sugar, ripe mango and unripe mango. And you have to taste them one by one and make a record somewhere in your copy. And you must observe or you must see that lemon juice, orange juice, grape juice, tamarind, vinegar, curd, unripe mango, they all will taste sour, whereas baking soda will taste bitter. Sugar and ripe mango will taste sweet and common salt will taste salty. Now, the sour taste of most of the fruits and vegetables is due to the presence of a substance called acid. The word acid, it comes from the Latin word acere, which means sour. So we can say that the sour taste of some substances is due to the presence of acid. Different substances contain different types of acids, like lemons, grapefruits, oranges. They contain citric acid, which is responsible for their sour taste. There are some fruits and vegetables which are rich sources of vitamin C, like amla, gooseberry. So they have ascorbic acid in them. Let's have a look at this table where the name of the acid is there and their sources are also written. First one is citric acid and it is commonly found in lemons, oranges and grapes. Then lactic acid, it is present in milk and curd. Acetic acid, it is found in vinegar. Tartaric acid, it is present in tamarind, banana, grapes. Malic acid is found in apples, tomato. Tannic acid in tea. Ascorbic acid in all the citrus fruits. These acids are basically of two types, organic acids and mineral acids. These organic acids are weak acids, whereas the mineral acids are strong acids. Organic acids are of natural occurrence and mineral acids are prepared artificially. Now both of them, whether organic or mineral acids, both of them can be dilute and concentrated. So we will study about each of them in detail. Organic and mineral acids. Organic acids, as I have told you, they are of natural occurrence. So acids that occur naturally are called organic acids. They can be obtained from plants and animals. And the example for organic acids are citric acid, ascorbic acid, etc. Mineral acids, they are artificially prepared. So the acids that can be prepared from naturally occurring compounds called minerals, they are called the mineral acids. And the example for them are hydrochloric acid, sulfuric acid, and many more. And they are usually found in science laboratories. All the naturally occurring acids like lactic acid, citric acid, ascorbic acid, etc., which are present in plants and animals, they are the organic acids and they are also the weak acids. And acids like hydrochloric acid, sulfuric acid, nitric acid, which are commonly used in the laboratories, they are the mineral acids since they are prepared artificially and they are strong acids. They are so harsh that if they come in contact with the skin, they can burn it. They can burn holes in the clothes and can even damage wood. The tabletops in the chemistry laboratories are therefore given an acid-resistant coating just to prevent it from any damage caused by these acids. When carbon dioxide is dissolved in water, it makes carbonic acid. And this is a weak mineral acid, which is an exception. So soft drinks, soda, they contain carbonic acid, which is a mineral acid, but it is a weak acid. And it gives the tangy taste to these drinks. Dilute and concentrated acids. Before understanding them, just answer me. Imagine that you are preparing a solution of water and sugar. And initially you have put more amount of sugar than water. For example, you have taken 10 spoons of sugar in half cup of water. What will happen? You will get a thick solution, a concentrated solution. Why? Because the amount of solute which you have added in the solvent is more than the solvent, and therefore you have got a concentrated solution. Now if you add a glass of water to that concentrated solution, it will become a thin solution. Its consistency will change. So this solution will be called a diluted solution when you have added more water to it. So is the case with acids also. So we can say that the concentration of an acid tells us how much water it contains. Both organic and mineral acids can be concentrated or dilute. For example, hydrogen chloride is a colorless gas, and when it is dissolved in water, it forms hydrochloric acid, HCl. And if you dissolve a large quantity of hydrogen chloride gas in a small amount of water, what will you get? You will get a concentrated hydrochloric acid. But if you dissolve a small quantity of the gas in large amount of water, you will get a dilute hydrochloric acid. So this is the example of a mineral acid. Now let's take the example of organic acid. For example, it is also possible to form concentrated citric acid by dissolving more of the compound which is available in a solid form in a given amount of water, and dilute citric acid by dissolving less of the compound in the same amount of water. So we can say that it is possible to dilute a concentrated acid by increasing the amount of water. And it is also possible to concentrate a dilute acid by evaporating the water it contains. So if you evaporate the water content, you will get a concentrated acid. So to define dilute and concentrated acids, we can say that when no or very small amount of water is present in an acid, it is said to be concentrated acid. And if more water is added to an acid, it becomes diluted acid. Now here comes an interesting activity. This is an activity to write a secret message, and that too with invisible ink. You will enjoy this and you can do this by your own, but under the supervision of any adult. For this activity, you need lemon juice, a sheet of paper, a brush or an earbud, a candle, and a matchbox. Now what is to be done is just take the sheet of paper and dip the brush or cotton swab in the lemon juice and write your message on the sheet of paper with it. You have squeezed the lemon, took out the juice from it, and then dip your earbud or the cotton from which you are going to write, dip in it and write the message on the sheet of paper, whatever you want to write, and let the sheet dry. What do you see when the sheet dries? You will see nothing. Nothing will be visible there on the sheet of paper. The message has disappeared from it. And that's why it has become a secret message. And to read this message, you have to do some magic. And what is that magic? That magic is to light the candle and hold the sheet a few inches above the candle flame, like this in the picture, at certain distance from the paper. And then you will be able to see the message which you have written on the sheet of paper. And you will see that when you light the candle and put it at some distance from the paper, the message will be coming out in brown ink. So this is called the invisible ink. You have written your message on the paper, but it has vanished. It has gone somewhere. But when you did a magic, the message reappeared on your sheet. So this has happened because of the acid which is present in the lemon juice. Acids have a number of properties, and these properties make it easy to distinguish different acidic substances. So we have divided the properties of acids into physical and chemical. So let's see what are the physical properties of acids which can be felt, which can be seen. So the first property is that acids are sour in taste. And all the citrus fruits like lemon, orange, they taste sour due to the presence of acids. Then second property is that all acids are soluble in water. They release hydrogen ions when dissolved in water. The other property is that acids are corrosive. The strong acids cause burns on the skin and they can also destroy the fabric. They react readily with metals, and this is the reason they are never stored in metal or plastic containers. You must have observed, if you have seen in the laboratories, that these acids are stored in glass containers. And the last property of acids is that they change blue litmus red. And about this we will study later about different indicators. Litmus paper is an indicator to test the acid or base. So we will study about different indicators later. Now let's have a look at the chemical properties of acids. Acids react with metals to form hydrogen and a salt. The chemical reaction results into the release of hydrogen gas. All the dilute acids conduct electricity. The aqueous solutions of acids conduct electric current, which means they act like electrolytes. It means they carry the electrical charges. Acids react with bases to form salt and water. Acids react with carbonates to form salt, water, and carbon dioxide. This is an activity which will show that hydrogen gas is released when metal reacts with acid. In this activity, in a test tube, we'll take a small amount of any acid. For example, we have taken hydrochloric acid, HCl, and we'll put some metal strips, any metal. For example, I have taken the metal zinc, and we'll leave this solution for a few minutes, and we'll see that after some time, some bubbles are coming from the solution in the test tube. And if we bring a burning matchstick near the mouth of this test tube, we can hear the pop sound coming from this matchstick. This matchstick will burn with a pop sound, and this pop sound is the indication of the presence of hydrogen gas or the release of hydrogen gas from the reaction. To write this reaction, we can write it as, we have taken zinc metal, so I am writing the reaction for zinc, and we have taken hydrochloric acid, that is HCl. So zinc is reacting with HCl to give a compound zinc chloride, and hydrogen gas is released. So this is the chemical reaction for the process which I have talked about in the chemical properties, that metals react with acids to form salt along with hydrogen gas, and the presence of this hydrogen gas is proved by the pop sound produced by this burning matchstick. Acids are used in various ways. For example, acids present in fruits and vegetables provide us with essential acids required for our body, like from citric acid, ascorbic acid, lactic acid. We all get these acids from natural sources. Hydrochloric acid is the main component of the gastric juice, which is secreted in stomach, and it helps in the digestion of food. Acids are added to food as preservatives. For example, acetic acid is added in pickles to give them a sour flavor and for preservation. And if you can remember, acetic acid, we were getting it from vinegar. Acids act as rust removers. Steel used in the construction of buildings is treated with acid before painting. Then sulfuric acid is used in car batteries. Acids like sulfuric acid, nitric acid, they are used for manufacturing fertilizers in agriculture. Hydrochloric acid is used as a cleaning agent. It is used in homes for cleaning sanitary ware, windows and floors. Sulfuric acid is used in the manufacture of paints and dyes. So these are the various uses of acids. In this way, we have learned about acids, what are their different types, what are dilute and concentrated acids, what are the physical and chemical properties of acids, and what are their uses. In the next lecture, we will study about bases. Thank you.